Hi, welcome to EggTronics. In this video I'm going to show you two methods by which we can have a negative voltage. First, by using batteries. With me, here I have a 9-volt battery. Now if you measure the voltage across this battery using a multimeter, it says 8.62. It should be 9 volt, but this battery is a bit used. Now if you want to have a negative voltage, all you need to have is another battery. So in order to have a negative voltage and a positive voltage at the same time, all you have to do is connect two batteries in series and use the common point as reference to measure the voltage. In order to connect this in series, I'm going to use this clipper. I have connected both of these wires. This will connect both the terminals, and now the battery is in series. If we measure the voltage across the positive pin, we'll get a positive voltage, and if we measure the voltage across the negative pin, we'll get negative voltage. So that's how simple it is. But remember, in circuits where you use only a single source, we consider the negative of the battery as ground. But in this case, since you are using a positive voltage and a negative voltage, our ground is different from the negative point. Now let's say you want to use AA batteries. Now if we want to have a negative voltage, all we need is another cell. So we connect both of them in series, we'll get 3 volts. The voltage gets added up. But if you want to have a negative voltage, you put the batteries in holder, and if you use the common point of the battery here, where the positive of one battery is in contact with the negative of another battery, you will get plus 1.5 at one end and minus 1.5 at the other end. And similarly, you have to use this common point as ground. Now the downside of this is, in order to have a negative voltage, you need double the amount of batteries you would need for a single voltage. That is, let's say you want to have a plus 3 volt and a minus 3 volt. Instead of 2 cells, you would need 4 cells. So that a set of 2 cells will give you plus 3 volt and a set of another 2 cells will give you minus 3 volt. And you have to connect all 4 cells in series and use the center point as ground. And you can do the same thing if you want to get a negative voltage out of a power adapter. You need 2 adapters. You have to wire them in series, connect positive of one adapter to the negative of another, and use that point as ground. And the negative of one of the adapters will get a negative voltage with respect to ground, and positive of the other adapter you will get positive voltage with respect to ground. Again, the downside of this is you need 2 adapters. But if you want to have both positive and negative voltage by using a same adapter, well, you have to build an adapter for yourself, and I'm going to show you how you can do that. This is another method to get a negative voltage for your projects by using a center tap transformer. Compared to a normal transformer where you have 2 wires for your high voltage connection, that is where you connect 230 volts, and on the other side you have your low voltage where you get your 12 volt or 15 volt. In a center tap transformer you will have 3 wires. In order to construct your own adapter, you need few components. You need a center tap transformer, a full bridge rectifier, and 2 1000 microfarad capacitors. Make sure voltage on the capacitor is greater than the voltage of the transformer. The transformer I have is an 18018 transformer. Let's connect this to the mains voltage and check the voltage with a multimeter. This is just a connector. Now I'm going to connect this to an AC supply. As you can see, I'm getting 20 volt between the center point and at one end, 20 volt between the center point and the other end. I told you before this is an 18018 transformer, but it is giving me 20 volts because the manufacturers of the transformer deliberately designed the transformers to give an extra 2 volts to compensate for the drop across the full bridge rectifier. Full bridge rectifier I'm using is W10, and on this chip all the pins are marked. Let's go ahead and do the connections. Now please don't do it the way I am doing it, as this is unsafe and the wires can get easily shorted. I'm just doing it this way for the sake of demonstration. Now if you wire it this way, we use this wire as ground point and you'll get a positive DC voltage between the ground point and the positive of the IC, and you'll get a negative voltage between ground point and the negative pin. Now we know the full bridge rectifier doesn't give us pure DC, it will be pulsating DC. So in order to fix this, we will add the capacitors. Now to get positive voltage, you have to connect negative of the capacitor to the common point and positive, the longer lead, to the positive of the bridge rectifier. Now at the negative voltage side, you cannot do the same as you did here. That is, connect positive terminal of the capacitor to the negative point and the negative of the capacitor to the ground. We cannot do that. The reason is, in this case, this point is more positive than this point. But in the negative voltage, our ground point is more positive than the negative point. So we have to connect positive terminal of the capacitor to the ground point and the negative terminal of the capacitor to the negative terminal of the bridge, where we are getting a negative voltage. So now it's ready. I'll say it again, please don't do it the way I'm doing it. I'm doing it this way only for the demonstration purpose, as this is unsafe. Let's go ahead and connect this to an AC supply. Now put our multimeter into DC because we are expecting a DC voltage. This is our ground terminal, so we have to measure the voltage with respect to ground. See, although this is a 18018 transformer, we are getting a positive 28 volt DC here and a negative 28 volt DC here. The reason we are getting such a high voltage is because there is no load. Once we add the load, the voltage will drop down. So this is it. This is a simple way you can create your own power supply where you can get a positive and a negative voltage by using a center tap transformer. Now if you want to have a desired constant voltage, you can do that by using linear regulators. Let's say if you want to get a positive 12 volt and negative 12 volt, you can use this 7812 to get a positive 12 volt and 7912 to get negative 12 volt, and wire them according to this circuit diagram. For your projects, if you want to make a dedicated power supply, solder all these components on a general purpose PCB, circuit diagram of which you can find in the description below, and enclose all of this in a small plastic box to have a compact power supply. I hope this video helped you. If it did, please like and subscribe to the channel. As always, see you again.